This is the real Tom Rose, and we're dealing with a really hard problem here. Almost no one gets this right. And the reason for that is because there are so many opportunities to make a mistake here. First of all, the problem starts out with a familiar type, which is they're defining a custom function. And they're not only defining a custom function, but they're defining a custom function in prose, not with an equation. The area of a square with length x. The area of a quarter of a square with length x. Now, people in general tend to be poor performers as a group at made-up functions. People as a group will be even worse performers at made-up functions that have to be translated first. So let's tackle this just to kick things off. And this is already a massive source of error on this problem. We need to translate this function q of x into some kind of algebraic equation so that we can use it, because we're going to have to use it at least 3 more times. I'm going to start out by drawing a square so that I can have a prayer of visualizing this. Q of x is defined as the area of a quarter of a square. So let me draw a quarter of this square with length x. So the length of that square is x, and q is going to be defined as the area of a quarter of it. Well, how do you calculate the area of a quarter of a square? Well, we need to know the length of the sides. If it's a quarter of the square, this will be x over 2. Think about that. I'll draw in the missing lines on this square, and you see this square is in 4 parts here when you divide the sides in half both ways. So that quarter of the square has a length x over 2, and the area of it will be equal to that side squared. So that's what I'm going to use as my function. So let's write that the following way. Q of x, right, is equal to the area of a quarter square, which is equal to x over 2 squared. Now, this problem changes into another familiar form that we've seen, which is you've been given some information and you're asked to find something. We've been asked to find a given q6 plus q8 equals qa. Now at first this is a really tough thing to answer, but now we at least have a rubric. We have a tool that we can use to begin to solve it. Now for each one of these, I'm simply going to plug the value in the parentheses in for x. So for example, q of 6 will become 6 over 2 squared. Q of 8 will become 8 over 2 squared. And q of a will become a over 2 squared. When you simplify this a little bit, we get 6 over 2 is 3, squared is 9. 8 over 2 is 4, squared is 16. Equals, and we'll have to leave this as is for now, a over 2 squared. 9 plus 16 is 25. So 25 equals a over 2 squared. And I'm going to take square root of both sides of this equation, and what will turn up, follow this up here, is 5 is equal to plus or minus a over 2. Anytime you choose to use a square root sign, remember to include a plus or minus. So now, if we want to be really diligent about this, it forks into 2 scenarios, which is and I'll put the two scenarios in two different colors. Scenario 1 says 5 equals negative a over 2. The other scenario, put in purple, is 5 equals a over 2. Now, one of these is possible and one of them is not. And we can eliminate this one because we're not going to have a negative area. So remember that Q is defined as the area of a square. And you can't really have a negative area. So I'm going to stick with positive numbers. And down here, we're left with multiplying both sides by 2. And we end up with 10 equals a, which will be your answer. So plug in 1, 0.